Here we are with continuing with section 6.3. So we saw some application problems where we had to find the probability, and it is given something like this. Now we look at some more applications, and these are with the word problems. So let's see how we will use it. So example 2, body temperatures of adults are normally distributed. Now this is the word that you should be looking for. So sometimes it would say are normally distributed, or the distribution is close to a normal distribution, something like that. So the word normally distributed or close to normal distribution or almost normally distributed. So these are the words you should be looking for, so that if you have that case, then you can use the z-score table. So it says with a mean of 98.6 Fahrenheit and a standard deviation of 0.73 degrees Fahrenheit. So this is the information given to us. I will put it here. Mu is equal to 98.60 Fahrenheit, and the standard deviation, so sigma is 0.73 degrees Fahrenheit. And then we are given what is the probability of a healthy adult having a temperature. Okay, now this is fixed. This is for each the AB parts. This is fixed. I won't write that over and over again. What is different here is x is now here 96.90 Fahrenheit. And what are we looking for? So we have to find probability that x is less than this. So we are saying this the temperature of a person is the random variable x. For example, if we start taking the temperature in this room, in the classroom, we will have a temperature of each individual might differ from the other, so that is the variable. So probability that x is less than 96.9. This is what we want to find. Okay, in the calculations we usually do not put the variable, so I will just write it. So for that, what do I have to do? I mean, we cannot compare the x temperatures directly, because they will be at different curves. So the easy way to compare them is by using and we don't have the tables of values only for the z-score, so we have to convert x to the z value. Find the z value for the x. So formula is x minus mu over sigma. So x is 96.9 minus 98.6 divided by 0.73. So when you do the calculation, you get negative 2.33. So this is the z value. Okay. Now for this z value, what is our, so you can put an arrow here, or basically what we can say over here, this is the same as the probability that z is less than negative 2.33. So now we look up, and when you look up, you will look up the negative 2.33, and you will see that you get the value 0.0099. So that is the probability. That is our answer. So in all of these problems, this is what you have to do. So here the x is this. So this is x. So I find the z-score for that. That will be 97.6 minus 98.6 divided by 0.73. Which gives me negative 1.7. Which makes sense because we have the x is smaller than the mu. But now it is greater than. So what I'm trying to find is the probability that x variable is greater than 97.6, or which is the same as probability that z is greater than negative 1.7. So in order to look up this one, what do I have to do? I have to either do 1 minus the probability that z is less than negative 1.7, or I have to look up the opposite. So this will be, I can say probability that z is less than 1.7. Same thing. So when I look up this one, I get 0.9147. So this is the probability that the temperature might be, so quite a high probability, which makes sense. Okay, what is the probability that the temperature will be between these two numbers? So we have to find the z for each of them. So this will be x1 and this is x2. So what is z1? z1 will be 98 minus 9.6, 98.6, which comes out to be negative 0.82, and then I find z2, which is 99 minus 98.6 over 0.78, which comes out to be 0.55. Okay, so we are trying to find probability that 98 is less than x is less than 99, which is the same thing as probability that negative 0.82 is less than z is less than 0.55. So which means I will look up the bigger one, which is 0.55, and that is giving me 0.7088, and minus, look up the negative 0.82, and we get 0.2061, and which comes out to be, when we subtract, 5027. So that is our answer. That is the probability. Okay, the next one is saying less than this number and more than that number. So again, we have to find z1. Oh, we already have the 99 one. I'm not going to redo it. So z1 is equal to negative 0.82. What is z2? No, wait a minute. No, z1 is different. Okay, sorry. We have to recalculate the z1. So z1 will be equal to 98.6 minus 98.6, or 99.6 minus. Okay, wait a minute. So z1 will be 99.6 minus 98.6 all divided by 0.73. And what will that give you? Well, I got 1.37. Does that make sense? Yes, because it is positive, because the numerator will be positive. So z2 is 100.6 minus 98.6 divided by 0.73. So this is giving me 2.74. So now, well, I didn't do the table here. So here we had negative 0.82, and then we had, so they will be very close to 0.55. So we were looking at the in between. So now we are looking, so we have 1.37, let's say it's here, and then somewhere here is 2.74. So now we are looking at this and this. So we have to take out the inner one. Okay. So this one is probability that z is less than 1.37 union or z is greater than 2.74. So we can also write it like this. We can say this is probability that z is less than 1.37, or union, which changes to plus sign when we are doing the probability, plus probability that z is greater than 2.74. So find the probability here, find there, and then we add them. So the first one, probability that z is less than 1.37, remember we have done something like that before. So that is 0.9147 plus, now this will be a small number, which actually when I look up, it's giving me this value. So I add them up, 0.9175, that is the probability we get. Okay, now these two last ones are a little bit tricky, but what you have to remember whenever you see this phrase, differs from the population mean by more than, or the other one is differs from the population mean by less than. Okay, differs and less than, and differs and more than. So this is what you do. So let me first explain what is happening. So notice here, if you what if your mean is 98.6, what will be the number which differ, or numbers which differ from this mean by 1? Well, one of the number will be when we take one less, like 97.6, and the other will be 98.6, 99.6, sorry. So these are the numbers which differ from the mean. And actually, let's take a simpler example. Let's say the mean is 10. So one less, this is 10, one less means 9, and one more means 11. So if we are to stay here, or if I pick a number in between here, what do you think will be the difference of that number from 10? Well, that difference will be less than 1. So this situation, if we want less than, then it means we should be calculating the area here, but that goes with this piece or this part. Now here we are saying more than, so it's in the same situation. If you pick a number over here or here, the difference of this number from the mean, or the difference of this value from the mean, will be more than 1. So that is the case here. So this means we have to calculate the area over here. So seeing this situation, okay, so here we are trying to, now there are two ways. One is a little bit less calculation and one is more calculation. So we know that the mean is 98.6. So it says the difference of 1. So it means our x1 will be 98.6 minus 1, and the x2 will be 98.6 plus 1. So this way you can calculate the two values, two x values, which in the previous parts were given, but in this part we can do this. So I got 97.6 and this gives me 99.6. So now I can look up these, find the z values of each of these, and then look up those values. So z1 of this will be, well, if you notice the difference of the mean, and that, so it will give me -1. Can you see that? -1 over the standard deviation, which is 0.73. And the difference in this case will give me V2, for this will be 1 over 0.73. I mean, like, I have not calculated yet, but I wanted to show you something else. This is what I have, and now I can go ahead and divide it by 0.73. So in this case, I am getting 1.37, and this is giving me 2.37. Sorry, 2.74. Point 74. Okay. So now we can go. Oh, sorry, my bad. by more than. Okay, so this is actually, they should give me the same value. So this is giving me 1.7, negative 1.73, then this should give me 1.7, because we are dividing by the same number. 1.37, and this is negative 1.37. Okay, so now basically this one is, remember this is, we are looking at area here because we want the difference to be more than, the difference should be more than 1. So remember I showed you this will be 2 times, so the probability will be equal to 2 times, and we will now look up negative 1.37, and it is 0.0853. So multiply by 2, we end up getting 0.1706. So that, now remember, when you calculate the probability, you must check it that it is a number less than 1, and also it is not a negative number. So because probability can never be negative, and it can never be more than 1. Okay, the last problem here. So now we have to see what about that the probability differs from the mean by less than 2. So now if you note again, if I do it the same way that I was doing above, so x1, and instead I do this, that the probability that the z is basically equal to, but remember it will be plus or minus of 2. The difference in the mean and the number is 2, so it will be plus minus 2, because that's how we get our x, and divided by sigma 0.73. So I don't have to redo all that stuff. If I remember that x minus mu is, this is what this means, differs from the population by plus minus 2, because remember x is equal to, one of the x is going to be mu minus 2, and the other will be equal to mu plus 2. So if I subtract mu from this one, I am getting x minus mu equal to negative 2, and here I am getting x minus mu equal to 2. So we can just say that the x minus mu, the top will be the plus or minus 2, and then we divide by the so this is giving me, what will that give me, 2.2 divided by, okay, I don't have that over here, let me see, 2 divided by 0.73. You guys should be able to do that. So I'm getting 2.74, but this will be plus minus. Okay, and now because it says less than, so it means I have the number negative 2.74 here and 2.74 here. I want the inner area. So what happens when we look up, we will look up negative 2.74. So negative 2.7 is here and 4 is here, 0.0031. So I take that, so probability will be equal to 2 times 0.0031 will be equal to, will that be true? No, that will not be true, because this is going to give me the area over here. So what should I do? I should be subtracting this from 1, so that will be my probability. So probability 1 minus so 1 minus 2 into this will be give me 0.0062, which is equal to 0.9938. That will be the answer. So this is how we can find these probabilities. Now we will go to section 6.4 in the next video, and that is we will be going actually backwards. Now in almost every example we were given x and we converted it to z-score, and then we moved on to find the probability. Now in the next section you will be given the probability and you will have to get z, and then from there you in some problems you have to get to x. So see you there.